So when you talk about the arithmetic sequence, so in this part, what we have is we have the same common difference, like for example, 2, 5, 8. So each term, that is like obviously if you wish to predict the next one will be 11, then 14 and so on. So the difference like will be, for example, if you have A, B, C, D and so on, then B minus A is the difference, C minus B is the difference, and D minus C is the difference. So the difference is generally the same. So if, for example, let's say sometimes the terms go on with the decreasing value, like for example, let's say 8, then you have got 5, then you have got 2, and so on. So this is also geometric sequence, but with the difference of -3. So here the difference is -3. Now in this case, generally the question that is asked in international math is to actually predict the next few terms and find the nth term formula. Now, nth term formula is represented by several ways: Tn, Un, or like, An. All these mean the same thing. It's just representing the nth term formula is nothing but first term, which is A plus n minus 1 times difference. So let us say for this question, if I wanted to find out, let's say 2 plus, first one I'm finding, so 2 plus n minus 1 times difference. Difference is nothing but 3. Now, what exactly is n value? Now, n is the position of the term. Like, let's say, for example, you're finding a 1000th term or 2000th term. It is very difficult to go with a pattern. So in that case, you just plug n value, you get the answer. So n is the position of the term, and Tn is the value of that term. So here it will be 2 plus 3n minus 3. And if you open the brackets, it will become 3n minus 1 as the nth term. Now, if you want to test it, like if you plug n as 1 here, if I plug n as 1, you'll get 3 minus 1, which is 2, obviously true. If I take n as 2, if I plug n as 2 here, so 3 2s are 6, 6 minus 1 is 5, that's true. So you can cross-verify your answers. Now, the second one is where you see that you have the difference that is negative. So if your difference is negative, so for example, 8 plus n minus 1 times difference, which is -3. So this will be the nth term formula here. It'll be 8 plus, so it'll open the bracket, it'll be minus 3n plus 3. So this is the formula which you have. So 8 plus 3n is 11 minus 3n. Just be mindful of opening the bracket with changing the sign so that you can comprehend it correctly. So this is the formula for arithmetic sequence. And there can be some of the useful stuff like, okay, find out which term will be like maybe 3000, 2099, 2999. So in that case, you just equate this 3n minus 1 to 2,999. And so you get 3n is nothing but 3000. So n is nothing but 1000. So 1000th term, when you find out, will be the 2,999 according to the first sequence. So this is the use of the arithmetic sequence. Now, as far as the geometric sequence is concerned, now in geometric sequence, you will have the same common ratio. Like for example, let's have 3, 6, 12, 24, and so on. Or you might have like the term with the falling ratio. I mean, the falling values, which is like 6, 3, then you will have like maybe 1.5 and so on. So here what you notice is the ratio, which is second upon first term, will be 6 over 3, which is 2. Then another thing is the ratio here is 12 over 6, which is 2. Another one is here 24 over 12, which is again 2. So the ratio, if it is the same, if you're for the given particular sequence, then you call it as to be geometric sequence with the ratio R. Here, if you see the ratio is 3 upon 6 is nothing but half. 1.5 upon 3 is nothing but half. So these are with the geometric sequence. And in this case, when you want to find out the nth term formula, nth term is nothing but a times ratio to the power n minus 1. So a is the first term, is which is basically, let's say in this case is 3. Ratio is 2 to the power n minus 1. So you leave it here. So this is the formula for nth term for this particular sequence. Now, second one is like in this case, it'll be nth term will be 6 times half to the power n minus 1. So the formula for the geometric sequence, which I would recommend to by heart, is a times ratio to the power n minus 1, u1 times ratio to the power n minus 1. Anyway, you can remember. Where a stand for the first term, r stand for the ratio, and n stand for the position of the term. So this is how you basically interpret the geometric sequence. Sometimes they ask you to write down, okay, which term will be equals to, let's say, if I give a numerical value here, let's say, for example, 96 in this given sequence. So if you solve for this, like if I divide 3 here, so 2 to the power n minus 1 will be 96 divided by 3, which is 32. So 2 to the power n minus 1 is 32. So what n value should I plug so that I get the answer as 32? So everybody knows that 2 to the power 6 is nothing but 32. 2 to the power 4 is 16. So 2 to the power 5 is actually 32. So n minus 1 is actually nothing but 5. So n gives you answer as 6. So this is how you basically do the sequences for the geometric. Now, as far as the quadratic sequence, now which is the 3 marker for paper to confirm, is given by like this logic. Now, for example, let's say I have a sequence which is like with 1, 3, then see, it's actually how I'm creating the sequence. You'll get clear probably once we do the answer. But right now it is 1, 3. Then let's say if I have this increase with a difference of 2, now next I'll increase by difference of 4, which is like maybe a 3 plus 4 will be 7. Then next I'll increase by difference of 6, which will be 13, and so on. So this is like a quadratic sequence for a reason, because when I find out the first difference, you'll get 2. This is 4. This is 6. Now, when I find the second difference, you'll always see that this constant. So if your second difference is constant, if second difference is constant, you will have the sequence will be in arithmetic. I mean, in the quadratic sequence. Quadratic sequence. Now, how do I find out the formula for it? Now, generally what happens is that there's a logic behind this. If I have a quadratic sequence as nth term formula is given by an square plus bn plus c, what I do is, if I write down the same thing and do for this sequence, at the end you will notice that if I take n as 1, a plus b plus c will be my first term. If I take n as 2 here, it will be 4a plus 2b plus c. If I take n as 3 here, it will be 9a plus 3b plus c, and so on. So what you'll notice is that if I take the difference now for these two, you will notice there will be 3a plus b here, and this will be 5a plus b. And if I subtract them, you'll get 2a. So what actually we do is we make use of this first row numbers in each of the rows. So this number is actually 2a. This number is 3a plus b. You need to remember this in order to do this question quickly. This is a plus b plus c. So from here, I get is 2a is nothing but 2. So I get a is nothing but 1. Then you get 3a plus b, which is equals to 2. So already we got a as 1. So it will be b equals to 2 minus 3, which is negative 1. Now, third one is a plus b plus c is 1. So a plus b plus c is 1. So if I take a as 1, 1 minus 1 plus c is 1. So that gives me c is nothing but 1. So logically, my nth term expression, when you find now a is 1, b is minus 1, c is 1. So it will be n squared minus n plus c is 1. So this will be the nth term formula for this given quadratic sequence. So this is how you do sequence for the basic international math type questions. Up till now, what I believe is that if you get any cubic sequence, what you do is generally like cubic sequence like 1 cube, 2 cube, 3 cube, and so on, which is like 1, 8, 27, and so on. So generally, like you need to be very mindful about like, okay, what's the sequence? Let's say this is n cube. Sometimes they start with like 8, 27, 125. In that case, if you see, this will be n plus 1 the whole cube. It's like it starts with n equals to 2. It's like n plus 1 the whole cube. So as far as the cubic is concerned, it will be more of this way rather than giving in a complicated form that we did like quadratic. So this is the summary of the revision for the sequence.